In this video, we are learning about mechanical properties of solids. Mechanical properties are two types. One is elastic behavior of solids and plastic behavior of solids. If you consider a rigid body which means hard solid, which can have different shape or size. But in reality, solid bodies are not perfectly rigid. It can be stretched, compressed, and bent. When an external force is applied, a body may get deformed. Take an iron rod and keep tapping it. It can be bent. We have applied external force on an iron rod. Iron rod is bending. When deforming force is removed, some bodies tend to regain their original size and shape, while others do not show any such tendency. Take an example of a plastic sheet. Plastic sheet, you can apply the external force, it bends. It bends. Now take iron rod. Iron rod we can't bend. If it is bent, it won't come to the actual position. Plastic sheet, after removing of the external force, it will come to the actual position some extent. Now we learn what is deforming force. A force which changes the size or shape of a body is called deforming force. So an example, take a plastic sheet or a rubber band or a rubber or any kind of. If you apply the external force, obviously the shape and size, it will be changed. So that force we can call it as deforming force. Elasticity. If a body regains its original size and shape after removal of deforming force, it is said to be an elastic body, and this property is called elasticity. Take a rubber band, apply the external force, which means deforming force. Cause of this force, a rubber sheet, a rubber band, the shape and size will be changed. So that is elasticity. Perfectly elastic body. If a body regains its original size and shape completely and immediately after removal of deforming force, is said to be a perfectly elastic body. After applying of the external force, after applying the deforming force, obviously the rubber band will be expanded. If you remove the deforming force, immediately it will reach to the actual position. Let's say it is at point A. After deforming force, it reaches to point B, the rubber band. You remove the deforming force, immediately it will reach to point B to point A, which is actual position and shape. That is perfectly elastic body. Now we can learn elastic behavior in terms of interatomic forces. Take a rubber strip. That length of a rubber strip, we can decide the points A and B. Apply the external force. What happens? The rubber strip will be expand. Once rubber strip expands, there is internal energy U. Let's say that is internal energy U. We can call it as a potential energy. And interatomic forces, which means before the rubber band, before expansion of the rubber band, all the interatomic molecules are stable. After expansion, these interatomic molecules are expanded, which means intermolecular energy occurred over here. That is potential energy U. As well, each and every molecules are separated with distance, which means R. R is interatomic separation. Interatomic separation. We can understand through graph what happens. The interatomic forces are the interatomic separation. R is large. In this case, the potential energy of an atom is negative, which keep on the molecules will be moved. Whenever molecules are moving, that is under kinetic energy, which means potential energy is negative. And the interatomic forces are attractive. Once you can see here, interatomic forces are attractive. At some particular separation R0, the potential energy becomes minimum. The potential energy becomes minimum. And interatomic forces becomes 0. So this R naught we can call it as normal or equilibrium separation. Equilibrium separation. Elastic behavior on the basis of spring ball model of solids. Consider any solid. There are the balls over the red color we mentioned over here. So an example is solids. In a solid, a mass point or a small balls connected to three-dimensional space through the springs. Here the spring represents interatomic force between the two atoms. Normally, the balls occupy the position of minimum potential energy or zero interatomic forces. When any ball is displaced from its equilibrium position, the various springs connected to it exert the resultant force on the ball. This force tends to bring the ball to the equilibrium position. So this model will explain the behavior of a solid in terms of microscopic nature of the world. Thank you for seeing channel.